Welcome to the first video in our three-part series on how SumiMap can revolutionize your cable documentation processes. In today's fast-paced world, efficient cable management is crucial for any organization. Join us as we explore how SumiMap streamlines documentation, enhances accuracy, and ultimately saves you time and resources. In part 1 of this series, we will focus on the benefits that SumiMap brings specifically to the outside plant cabling portion of your project. What is OSP? OSP cabling, or outside plant cabling, refers to the network infrastructure used for telecommunications and data transmission outside of buildings. This type of cabling is designed to withstand environmental conditions and is typically installed between telecommunications buildings, cell towers, and other outdoor locations. Now, let's dive in. In this video, we'll focus on the OSP segment of a cable run that starts at a fiber panel within the data center and extends into 3 separate buildings. Using our toolbar at the top of the screen, we'll start with the Geo-navigation tool, which leverages Google Maps imagery. This feature allows us to effortlessly pinpoint the exact location of our jobs anywhere in the world. Today, we'll focus on a small campus project just outside of Washington, D.C. As we explore the campus, you'll notice that each marker represents a key location in our project. Each of these markers has preloaded drawings attached, which you can access with just one click of a button. Whether you want to view detailed drawings of each floor of a building or the entire layout of the campus, the choice is entirely yours. In this segment, we'll begin by selecting the campus marker and then choosing our campus drawing. This view presents the entire layout of the project that we will be looking at today. Here, you can see the conduits connecting these buildings through the manhole system, clearly indicated on the layout. This visual tool allows us to effectively monitor the routing of our outside plant cabling, ensuring that our installation process remains organized and efficient. As we zoom into the drawing, we can observe the pipe run that exits from the data center in Building 35 and enters the manhole system. By clicking on the pipe itself, we can access the Attributes tab to view more detailed information about this individual object. Let's go over a few of those details. On the left side, if we click on Contents, we can view the cables installed inside of this pipe. We are showing a 25-pair copper cable, a 72-strand conventional fiber cable, and a fire alarm cable displayed here. Within the attributes, clicking on Photos reveals any job site images that may have been uploaded by the technician. Another great feature is the Exits option, which displays the entry and exit points for each side of the pipe. Now, let's return to the campus drawing and trace the duct bank over to manhole 5 to take a closer look. By clicking on the red manhole icon, we'll access its Attributes tab, just as we did with the pipe. On the right side of the page, let's click on the Cable Route Node option. From this vantage point, you can clearly observe each of the conduits along with their unique IDs that both enter and exit this manhole. Additionally, you can see where each conduit's next destination is, whether it enters another manhole or a building. By utilizing this feature, project managers can gain critical insights into the existing infrastructure of a duct bank, including the diameter and material of each pipe, the specific type of cables, such as fiber optic or copper, and the operational status of each line, whether it is active, inactive, or under maintenance. As we observed with the conduit, we have the capability to upload job site pictures, but we can also incorporate web links, similar to what we've done here under our Documents tab. For this project, we have chosen to include a web link for Struction Site, an online database that we frequently utilize with SumiMap to store images related to specific site locations. This integration allows us to leverage 360-degree images and even short video clips when necessary, enhancing our ability to document and visualize the worksite. This feature significantly improves our workflow by providing easy access to rich visual content that aids in project management and communication. Returning to our campus drawing, we can highlight what is referred to as a key map object, which is represented here by the pink circle over the manhole. A key map object is an interactive feature that, when clicked on, navigates you to another drawing within your project. This approach not only streamlines your workflow and allows you to layer multiple drawings in any configuration you desire, but also improves collaboration by providing a clear and accessible overview of interconnected drawings. This specific key map object will take us inside of Manhole 5. Let's check it out. In this overview, we can observe the manhole butterfly, which provides a straightforward breakdown of the contents within the manhole. The north and south walls feature conduits entering and exiting, while the east and west walls remain vacant. Each colored circle represents a conduit, indicating whether it carries copper, fiber, or fire alarm cables. Focusing on the splice case, we can open the attributes for one of the fiber cables to examine the details it contains. Under the Files and Documents tab for this 72-strand conventional fiber, we can access the uploaded test results from the installation, which provide assurance to the customer that their cable is functioning properly, as well as the corresponding spec sheets. This section contains all pertinent information related to the project, ensuring that we have comprehensive documentation at our fingertips. Now onto the splice case itself. We can highlight it and then utilize our SUMI Rack tool at the top of the interface to explore its contents. Here, we can see the 3 splice trays that connect our main trunk fiber from the data center to the 3 buildings that are being integrated into the network. To gain a clearer understanding of this connection, we can highlight each splice tray and then use our Connect View tool at the top. This will provide us with a detailed visualization of how each fiber strand is connected, facilitating a better grasp of the network architecture and flow of data between locations. Now that we have our 3 trays displayed in Connect View, we will select the first fiber strand from each splice tray to demonstrate its connection to the right. As we zoom in, we can observe the 24-strand fibers that exit our splice case within Manhole 5. This view clearly illustrates how these fibers connect to the 24-port bulkheads located inside the telecom room in each of the 3 buildings. This detailed visualization helps us understand the fiber routing and ensures that each connection is accurately represented, facilitating effective network management and troubleshooting. By selecting our 3 trays and showing connections to the left, we can demonstrate how the 72-strand fiber exits Manhole 5 and is spliced into the last tray located inside the data center. As we expand this final tray to the left, we can see how our 72-strand fiber is spliced into 3 24-strand fiber tails, which ultimately connect to the 3 24-port bulkheads situated within the data center. This clear depiction of the fiber transition underscores the efficient distribution of connections and ensures that we can effectively manage and understand the network infrastructure within this data center. Thank you for watching. In Part 2 of our SUMI Map series, we will concentrate on the riser portion of this project. We will explore the cabling system that extends from the main distribution frame, MDF, up to the telecommunications rooms located on various floors. This segment will provide an in-depth look at the infrastructure involved in facilitating communication throughout the building.